Hi Year 12s, here's exercise 14A, question 7. So we need to find the x-coordinates of the points on this cubic curve where the tangent is parallel to the normal at this point. So first of all we need to find the normal at that point, or at least we need to find its gradient, and then that will tell us what the gradient of the tangent is, and then we can work backwards to find the points on the curve. Okay, so if we want the normal at this point, we've got the coordinates here. What we need is the gradient. So to find the gradient, we are going to differentiate. So y is x cubed minus 2x squared. We differentiate, we get 3x squared minus 4x. Okay, and we're interested in the gradient at x is equal to 1. Okay, so if we substitute 1 in there, then we're going to get -1. So the gradient of the tangent is, at this point, is -1. So that means the gradient of the normal is going to be -1 over 1, which is, again, -1. Okay, sorry, negative of -1, so it's going to be +1. There we go. That's it. So we now know that the gradient of the normal at that point is 1. So that means the tangent is parallel to that, so the gradient of the tangent at the points we're interested in is 1. Okay. All right. So we can use this to help us identify where these tangents are. All right. Let's just have a little think. So we've got a cubic here, and we know that the gradient of the tangent at 1 minus 1 is -1, so that's a bit of a downhill bit. Okay, so the gradient of the normal would be perpendicular to that, and we're now looking for the two places where the tangent is parallel to that. So we're trying to find out what are these coordinates, what are the x values of coordinates at these points here. Okay, right, so gradient is 1, so that means that the derivative dy by dx is equal to 1. Yep, and we know the gradient is 3x squared minus 4x, that has to equal 1. So we've got a quadratic that we can solve, and that will give us the x coordinates that we need. So we start by making it equal 0, and then I'm going to cheat. If you have your graphical calculator, you can go to the equation solver menu, okay, and we can solve it. So I'm going to do that just because my brain's being a bit slow. So it's polynomial degree 2, and I put in the coefficients. Just think how lovely it'll be when you've got your graphical calculator. Okay, so we get that x is 2 plus or minus √7 over 3. So those are the x coordinates where the curve meets, so where the tangent is parallel to that normal. And I'll just check the values match the answers. So the answers we were given are 1.55, and that's the one with the plus, and -0.215, which is correct. Okay.